Independent and dependent probability. What does independent mean?
They can stand alone.
By itself. All right. So independent probability means the first one is by itself, the second one is by itself, and they don't have anything to do with each other. So the first one does not affect the second one. All right. So two events A and B are independent if the fact that A occurs does not affect the probability of B occurring. All right. We talked about this earlier. We said if it was an or, what did we do with the stuff?
You gotta combine.
You gotta combine.
If I said probability of A or B, probability of a king or a queen.
Don't you add all that?
Add them. Add them. That's it. If it said or, we added. If it says and,
Whoever has the same.
if it says and in this, we multiply. That's the two differences. If it says probability of a king or a queen, we're going to add. If it says probability of a king and a queen, we're going to multiply. And we'll see how to do that when we get to the problem. Dependent means you rely on something else. So two events A and B are dependent if the fact that A occurs affects the probability of B occurring. We need to understand what this means right here. So when you see it later, you know what it's talking about. The probability of A times the probability of B, giving that A already happened. And it'll make more sense, I think, when we're doing the problems, but that's what we need to know about this part right here. When you see that little line right there, it's saying the probability of B given that A already happened. All right, examples of independent ones, tossing the coin and rolling the die. When I flip a coin and then roll a die, does flipping the coin affect what I get when I roll that dice? No, not at all. So those would be independent. Choosing a card, replacing it, and that part right there is important. We're going to get to that in a little while, but replacing it is important. And then choosing another card. That's what we've been doing so far. When we've been doing the deck of cards problems, we've been choosing, replacing, and then choosing another one. We hadn't said that, but that's what we've been doing. Landing on heads from two different coins. First coin doesn't affect the second coin. Rolling a 4 on one and then a 3 on another one. Same deal, doesn't affect it.
Good morning, update.
All right, the last one. Picking a red marble from a jar, replacing it, picking green marble. Again, the replacing part is important. When we're replacing it, we're basically starting over. All right, here's some examples of dependent. Hopefully we'll figure out what those are. All right, so if I'm looking at all these examples, what's the main thing that we should pick up on?
Not replacing.
Not replacing. Not replacing is what changes it and makes it independent. Or excuse me, dependent. Because think about the cards. If I pick a king the first time, how many cards do I have in the deck?
No, 52.
I've got 52. If I don't replace that card, the next time I pick, how many do I have? 51 instead of 52. So that changes what we had. So that's what the dependent stuff is going to look like. All right. Copy these down and tell me, are they independent or dependent? All right, first one. Picking two people out of a crowd. Independent, because picking one person and picking another person, what the first person says has nothing to do with the second person. Picking a book from the shelf, not replacing, picking another book. That is dependent. If you ever see the not replacing, that's dependent. Picking a 7 from the deck of cards, replacing it, and then picking a 9. That's independent. Because when I replace it, I'm starting back over, and the first one doesn't affect the second one.
Okay, so not replacing would always be
Dependent.
But if you're replacing it, change it.
That's going to be independent. All right. Picking two cards from a deck and both are kings. That one's dependent. Even though it didn't say the not replacing thing, you got to think about it.
You're not replacing it because they're both kings.
Because I'm picking two of them at the same time. So I didn't replace anything. That would make it dependent. All right. Jar contains, which one? Red and green and blue. A jar contains 3 red, 5 green, 2 yellow, 6 blue marbles. A marble is chosen at random from the jar and is replaced. So what kind is this? Independent. First one doesn't have anything to do with the second. All right. Red and green. All right, so red. How many reds are there? Out of?
16.
16. So for picking red, it would be 3 out of 16. I know and means times. And since I'm replacing it, my bottom number is going to stay 16. How many are green?
5. 5 times 3 is 15, so it'll be 15 or 16, right?
16 times.
You got to multiply.
Multiply top, multiply the bottom. But you got the calculator, so just type it in there.
And then simplify that. That's it.
If it can be, yeah. All right, do
Yellow and blue.
yeah. See if you can do the rest of those. Can we? Think so? Yellow and blue. What's my numbers?
2 or 6.
That's gonna be a 3/64.
3 over 64. All right. Blue and green would be,
6/16, 5/16.
which is? Say it again.
15
All right. Green and yellow. All right. The last one has 3. Well, you do it the same way. Red would be 3 out of 16 times green, which is times blue, which is
6/16.
just multiply them all out.
90 of 4,000.
Huh?
9.
No.
45 over 2,000.
Over 200.
Over what?
You gotta simplify it.
Yeah, it's 2048 when she says
All right. Are there any questions on those? If it's independent, replacing it, we're good. Type in your numbers, you got your answer. All right, 7 and 9. How many 7s are there? Out of 52. Since I replace it, it stays 52. There's 4 9s, so I'll multiply those out and get 1 over 169. Is that right? All right, red, 26 out of 52 times odd. All right, make sure you understand that 20 right there for the odd, because people were missing that on the test. All right, odd and even for the deck of cards is 20. Answer here is what?
5 over 46.
5 over what?
46.
All right. A club and a number less than 7. Well, club is 13 times a number less than 7 would be what? 24.
No, I missed one.
And my answer there is
3.
3 over 26. Not a 5. How many are not 5s? 48 out of 52 times king, 4 out of 52. All right. A black 4. How many black 4s are there? 2. And a 3. There's 4 3s. 1 over what? All right. On these, the biggest thing it says not replace. That tells me automatically it's dependent. So what happens? The first thing affects what happens the second time. I'm still going to start like normal. So this was what, 16?
Yes.
All right. So there's going to be 16 choices to choose from that first one. But for the second one, there's only 15. We good with that? Because when we take one out, we're not putting it back in, so now it's going to drop down. So red is still 3. Green is 5. So now I'll be working that problem like that. So the thing with dependent is it's going to start dropping for the denominators. Every time you pick something out and leave it out, it's going to make it smaller. So yellow and red, I know it's going to be 16 and 15.
Why though?
Because when I'm picking that yellow one out the first time, so that one yellow is gone.
So there's only 15.
And now there's only 15
okay.
choices left in the bag. So yellow would be 2, red is 3, 1 over 48. All right, so if I want to do the blue one here, I know that's going to be 16. And there are 6 there. Red is gonna be 3 over 15.
40.
Then go to yellow and not blue. So yellow is the 2. Not blue
9 over 15.
will be 10, right? Or 10 out of 15. Is that right?
No.
There's 16
Not
more.
blue.
There's 16,
16.
but there's
So
15 there.
Yes. Yeah.
Are we okay with the 10? We shouldn't be.
Much? Oh, wait,
I said-
one less.
There's a 15.
How many,
Yeah.
what did I do here?
You got one
I
out.
took out
And you
one
didn't
of the not
replace it.
blues.
So
So
16.
wow.
So instead of 10 not
there's only gonna be
blues,
one yellow. So it'd be 9.
there's only 9. Does that make sense now?
That's
I was thinking that, but I didn't.
Alright. You gotta read what it's saying and go with that. 3 over 40 again?
Yes.
We're doing 2 reds. First time is gonna be 16, we know the second time is gonna be 15. I have 3 reds to start with. When I take the first red out, that only leaves 2 reds for the second choice. So then when I multiply those out, so my answer on that one would be 1 over 40. I go to my next one over here, green and green. I start with 5 greens out of the 16, take 1 out, that leaves 15. Since I already took 1 green out, there's only 4 left. That answer would be 1 over 12. Go to the bottom ones, blue, red, and green. I know it's gonna be 16, and then 15, and then 14. So blue would be 6, red is 3, and green is 5. Multiplying those out, wind up with 3 over 112. And then green, blue, and green, I know I start with 5 greens out of 16. The next one for blue is gonna be 6 over 15. I know the last one's gonna be 14, but I've already taken 1 green out. So instead of 5, there's gonna be 4 of those. And that one winds up being 1 over 28.